Welcome students. Actually, in the previous class we discussed about what is sound and how sound propagates through different types of medium and also some terms which is related to a sound wave. Now today actually we discuss about characteristics of sound. Characteristics of sound, and actually there are total three characteristics of sound. One is First one is actually loudness or intensity of sound. Loudness or intensity of sound. And the second one is actually frequency dependent, that is pitch of a sound. And the third one, that is quality or timbre. Now the first we have to discuss about actually loudness or intensity. What is loudness or intensity of a sound? Actually, loudness is a characteristic of a sound which distinguishes a feeble sound from a loud one. Okay, of the same frequency. Suppose we take two instruments which have actually both have same frequency, but their actually amplitude or intensity is different. That is, loudness is the property by which we can distinguish actually a feeble sound from a loud one, okay, or larger one. Suppose we take two different actually waves like that. One wave like this one, this is the one wave, and in this same case, suppose from this same graph we can take different one, that is suppose with the help of different color, suppose this one. Okay, so from this case actually we already know what is time period, how we can find out time period or amplitude. From this case, suppose this is wave number 2 and also this is wave number 1. Okay, from this case actually if we point out from those case actually here is the point O, and this is A, and this is B, and this is C. So for these two cases actually one wave means actually or one oscillation, that means wave started from O point and wave ended actually at B point. O to B, that is one complete oscillation. So time taken for both cases is same to complete one oscillation. That means here t is same, time period is same for both case. So we can say frequency also same for both case. But what is the difference between two waves? Actually the difference is the amplitude. Okay, for the second one actually if we this point this P and this point is Q, so for two number 2 wave actually the amplitude A is equal to ultimately OP, and for case 1 actually or wave number 1 amplitude A, this is A2 and this is A1 is equal to, we can say, OQ. And from this figure we can easily see that OP is greater than OQ. That means actually we can say the amplitude of second wave is more than the amplitude of first one. So in this case actually loudness of wave number 2 is more than the loudness of wave number 1. So here actually loudness or intensity of a sound is directly proportional to amplitude. Okay, that means actually if amplitude is more, loudness also becomes more. Okay, so this is the property of a vibrating body that defines the amplitude also, and also that defines or distinguishes the sound or loudness of sound from different one, okay, or feeble sound from a louder one, okay. And also some other factors on which actually loudness of a sound depends, that atmospheric temperature also, pressure also, velocity, etc., and also amount of moisture, okay. Here are some factors that is actually on which actually also loudness depends, that is atmospheric pressure, okay. So we can say atmospheric pressure, and we can say temperature, and also velocity, etc. Okay, now we move to our next actually point or next characteristics of sound, that is pitch, okay. Pitch of a sound, the second one is actually we can say, the second one, that is we can say pitch. So here we take the second one, that is suppose pitch of a sound. Now the question is, what is pitch or pitch of sound? Actually, pitch means actually it is the characteristics of sound by which we can actually distinguish or differentiate a shrill sound from a hoarse sound. Okay, that means actually it directly depends on actually frequency. Simply we take to different wave again, okay. Here actually we draw two different wave. The first one is suppose this one, this is the first one, and also we take the second one, suppose this one is the first, and we take the second one, that is suppose we draw in this same graph, this is your the second one, this is your the second one. From this figure actually we can notice that if we draw amplitude for both cases, here actually amplitude for both cases is same, okay. This is the amplitude line, and we can see that the amplitude for case 1 and case 2, okay, this one actually case 2, okay. Amplitude A is same for both waves, okay, for wave 1 and 2, okay. Now but the time period is different, okay. Capital T is different. Suppose here if we draw the points, this is O, this is A, this is B. For question number actually wave number 1, for one wave actually time period is taken to complete the wave, that is O to B. And for case 2 actually time period is the time to take in the complete the wave, that is actually O2 here. So from this figure the time period for O1 is more than the time period for case 2. That means actually time period is more for O1 means actually frequency is less for O1, okay. Here we can say actually we know the relation between time period and frequency, that is T is equal to 1 upon F. And here we can say that the frequency as time period for 1 is more than time period of 2, that means frequency of 1 is less than frequency of T, okay. So from this case we can distinguish with the help of actually frequency, we can distinguish two different waves as their amplitudes are same, and as frequency of one wave is more than frequency of frequency of 1 is less than frequency of 2, that means actually pitch of 2 is pitch of 2 is greater than actually pitch of 1. Okay, so this is the relation. And the next one, that is the option or point number 3. Okay, that is actually quality or timber. The third characteristics, that is quality or timber of a sound. We can say quality or timber of a sound. Now the question is, what is the definition of quality or timber? Okay, so actually it is the characteristics that distinguish two different notes of the same pitch and also same loudness produced by different bodies. Okay, that means suppose one body, we take this is one body one, that is suppose body one, vibrating body one, and the second one, that is actually vibrating body 2. Okay, and they produces the two waves actually having amplitude and frequency is same. Okay, amplitude is A is same for both cases, and also frequency F is same for both cases. But with the help of quality or timber, we can distinguish two different body. Suppose this is tabla, or we can take this is float. As the frequency and amplitude is same for both cases, but we can distinguish easily what sound is for tabla and which one is for flute also. Okay, so this is the actually quality of timbre. Okay, so actually it depends on quality or actually timber, that is actually not depends on actually amplitude frequency. It actually depends on uniform pattern of secondary waves, that calls actually harmonics. Okay, so for two different cases, actually two different waves, that means two unique pattern of secondary waves created, that is called harmonics. That is why actually as amplitude and frequency is same, but we can distinguish easily the both two actually sound instrument or vibrating body. Okay. Now we just move to our next case, that is suppose music and noise. The second one is, or the second topic, what is music and what is noise. And we have to actually also distinguish what is music and what is noise. In generally, we can say that the some sounds are very pleasant to our ears and some sounds are very unpleasant. For example, suppose the sound of violin is pleasant, but the sound of traffic is not. Okay, that means actually some sounds are pleasant, that is called actually music, and some sounds that is are unpleasant, we can say that is noise. Okay, in generally, music created due to regular vibration and noise created regular due to irregular vibration. Now the suppose if we have to distinguish music and noise, what are the difference between music and noise? We can see it is pleasant, we can tell that for music cases it is pleasant and it is unpleasant. Or second one, this is produced for actually due to regular vibration. Okay, and this is produced, noise is produced for irregular vibration. Okay, of a vibrating body. And here for music cases, amplitude of vibration and frequency do not change suddenly. Okay, that means actually amplitude or frequency don't change suddenly. Do not change suddenly. Whereas actually for noise cases, amplitude and frequency change suddenly. A and F change suddenly. And the last one, that is actually here waveform is regular. Here we can say waveform is regular, and whereas actually we can say waveform is irregular. So actually this is the difference between music and noise. In the next class we discuss about some musical instrument and how we can find out loudness. Okay, and this is the end of today's class. Okay.